One thing that happened to me, was really my only bad experience with Rivian. My wife and I went for a flight down to Tampa, Florida for 3 or 4 days, and we came back. The truck had 70% battery. It was completely dead.
How smart mechanics beat dealer lockouts, the aftermarket jailbreak method. You handed over the money, you drove it home, and the second you lifted the hood, you discovered you did not actually get full control. Parts gone, software gates, dealer-only procedures. This is happening across model lines and model years. But professional shops are not surrendering. They have developed repeatable, lawful approaches to get vehicles back on the road and back under owner control. In this video, I'll lay out the real practical paths shops use, explain the trade-offs, and show how owners can document and protect themselves. No hype, just what works and what you need to know. Why this matters. Manufacturers have been adding proprietary software layers on top of the OBD-II standard, and major service portals now gate programming and calibration behind dealer subscriptions and server authentication. That creates a market power problem. When parts or procedures are restricted, repair choice and price can disappear overnight. The result is higher cost, longer downtime, and reduced competition. I'm going to show you how the aftermarket solves this problem in ways that are legal, scalable, and defensible, and what you should never do because of safety, emissions, or legal risk. Path A: modern standalone engine management systems. The first and most common professional approach is replacing OEM dependency with an aftermarket engine management solution, a standalone or drop-in ECU from established vendors. These systems let a competent shop manage ignition and fueling without relying on manufacturer cloud services or dealer authorization. The benefits are clear: no server authentication, fully editable maps, and standardized diagnostic access. For owners, that means parts, repair, and tuning markets that respond to independent supply rather than dealer subscriptions. Important considerations. These installs require careful planning for sensor interfaces, harness compatibility, and systems that the OEM tied into engine control, for example, immobilizers, transmission controllers, and emissions monitoring. A responsible shop will document the installation, test all interfaces, and produce a written scope of work and warranty for their workmanship. Expect trade-offs in warranty coverage and resale value. Under U.S. law, the Magnuson-Moss Warranty Act prevents blanket warranty voiding, but you should document causation if disputes arise. Transmission and system dependency, 2 professional strategies. Removing the original equipment manufacturer engine controller can create downstream issues. Many modern transmissions, advanced driver assistance systems, and other vehicle modules assume the original equipment manufacturer engine control unit is present and communicating. Shops approach this problem in 2 ways. One is to install an aftermarket transmission controller or a standalone transmission control unit that performs shift logic independent of the original equipment manufacturer's network. The other is a mechanical conversion, for example, swapping to a transmission that does not depend on digital control. Both routes are engineering projects with costs, drivability implications, and compliance considerations. A professional assessment is essential before making a decision. A quick but critical reminder: changes that affect emission systems, airbag circuits, advanced driver assistance systems, or structural safety components can create legal and safety risks. Always check local emissions and vehicle modification laws, and use qualified professionals for any work touching those systems. This is not a bypass checklist. It is a responsible professional playbook. Path B: reproduce, reverse engineer, and substitute. When original equipment manufacturers discontinue a part, the aftermarket responds by reverse engineering and reproducing the component, or by building an electronic functional replacement. That can mean remanufactured mechanical parts, reproduced castings, or replacement circuit boards that perform the same function without relying on proprietary services. In many cases, these parts are engineered to be more durable and better documented than the original equipment manufacturer version. The key is to source from reputable remanufacturers and to keep full receipts and test reports. Good documentation protects both the shop and the owner if there is a warranty or safety question later. Standards, pass-through tools, and community calibrations. Another tool in the professional toolbox is the use of open standards and pass-through interfaces. For example, J2534 and other standardized programming interfaces, together with community-sourced calibrations or independently developed maps. These approaches allow independent shops to program or adapt replacement modules without dealer authorization in many cases. This is how independent shops keep practice viable for late model repairs, by relying on standards, the right tools, and shared technical knowledge. When using these methods, document everything and obtain code and calibration files from trusted providers. Path C, mechanical simplification and older architecture conversions. When electronics are scarce, expensive, or simply inappropriate for a vehicle's value, professional builders sometimes pursue mechanical simplification. That can mean replacing complex, failure-prone control modules with simpler, robust systems, or choosing engine and drivetrain architectures that predate modern software dependency. On older platforms, this can include legacy ignition systems or carbureted induction when it is legal and practical. These are engineering choices with implications for emissions, drivability, and resale. They are not casual weekend projects. Consult local laws and work with fabricators and inspectors who understand the regulatory landscape. The business model pros use to scale these solutions. Professional shops do this work at scale by combining 4 things: trusted parts networks, documented processes, customer warranties for aftermarket installs, and an information network to capture and share problem and solution cases. Rather than inventing one-off fixes, sustainable shops standardize components, keep stock for common failures, and maintain thorough documentation, which builds customer trust and strengthens legal defensibility. That's how the aftermarket turns a supply chain problem into a durable service offering. Legal and practical ground rules for owners and shops. If you are an owner facing a dealer-only lockout, follow these practical rules. Get a written explanation from the dealer that includes diagnostic codes and the specific reason they claim their procedure is required. Obtain an independent written diagnosis. Preserve all communications and receipts. File a formal complaint with state consumer protection authorities or your attorney general if needed. Avoid public posts that provide detailed instructions for defeating security systems and focus instead on documentation and lawful repair paths. If you are a shop, document technical decisions, provide written warranties for your work, and consult legal counsel for high-risk modifications. If this changed how you see ownership, hit like and subscribe. Drop your one-sentence report in the comments. Join the community. See you on the next video.